Hi, everybody. I bet you thought you totally got rid of me. And this is my weird camera, so my face is probably going to do some really weird stuff on here. Anyway, I just wanted to let you all know that I am working the election today, and I will be back tomorrow. So you all have just finished your gas law simulation. Yesterday we worked as a group back in the lab and did some gas law demonstrations and talked about pressure and all the things about pressure and gases that cause the phenomena we saw in the lab, the crushing of the can and etc. The balloon, the egg sucking. We really had a great time, did we not? Yay! We had a great time. Wasn't that great? Anyway, like I said, this is going to be a really probably bad recording just because my computer is a little slow. But I wanted to read out loud before you start to attack these calculations. And I know you're going, oh, Miss Tammy, it's math and we don't want to do math. These are easy. Just plug in the numbers. But before we start, I want you to grab a hold of the gas law calculation and what you need to know sheet that Mike, I believe it's Mike taking this afternoon. It might be Nick. It could be Amy. So sorry if I've messed up who is taking care of you today. But grab that packet and it says gas law calculations and what you need to know. So before doing gas laws, you've got to figure out all the terms. So the first part of this sheet has all the terms that you'll need to familiarize yourself with. Now, I know we went over them, but I know we sleep. Squirrel. Oh, how about not squirrel, but cow? Isn't this great? The cow on my head. So, grab that sheet. Go through these different terms, starting with ideal gas, Kelvin, what else is on here? Pressure, standard temperature and pressure, or STP. It's not the motor additive. STP stands for standard temperature and pressure, temperature and volume. Those are the words on your sheet. The second, on the second page, it talks about Boyle's law calculation. There is an explanation of what P1 and V1 stand for. There's also a question and how to set it up with the answer. So this is a great example. It's using 4 liters at 1 atmosphere. What will the pressure of a gas be if we squish it down so it has a volume of 2.5 liters? So it starts with 4, ends with 2.5, and it wants to know the new pressure. And as you found out, if you increase the pressure, what's going to happen to increase the volume, what's going to happen to the pressure? The next part is Charles' law, aka Chuck. No, not really. There is a problem at the bottom 2. Explanation of Charles' law, V1 over T1 equal V2 over T2. Volume V meaning volume, T again meaning temperature. It says we have 2 liters of methane gas at 40 degrees Celsius. And what will the volume be if we heat the gas to 80 degrees Celsius? So we do know also from yesterday and also from our simulation that the temperature also has effect on pressure and volume of gases. So if you have a Celsius degree, remember, we always do gas law problems in degrees Kelvin. So it walks you through how to change from Celsius to Kelvin and then plug it into Charles' law. So that's the second part. Third part explains Gay-Lussac's law. P1 over T1 equal P2 over T2, which is kind of just the the inverse of Charles' law. And there's no problem associated with that, but there may be a problem on your worksheet. And, of course, the very last one being the combined gas law. And If we didn't have to do all three of the other laws, we can use the combined gas law. If one of the parts of the gas law, if it's not asking you about temperature, says temperature is constant, and you leave the temperature part off. It says pressure is constant, you leave the pressure part off, and you end up with one of those three laws anyway. So it gives you the an example, a question, and an example of how to use the combined law. With that, as well as your sheet, you should be able to calculate pressure and volume with pressure volume changes, pressure and volume with temperature changes, and other gas law problems. We won't go too deep. These problems are pretty easy. I didn't get really heavy ones. It isn't necessary, but it is necessary that we understand how to use and calculate gas law equations, as well as understand what in the world these things mean. So hopefully you're writing down your questions, and if you have them for me, here's my ha ha ha. Ha 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 ha. Isn't that great? If you have questions for me, please write them down. If something just totally blows your mind, write it down. If you're like really super bored and you're going to fall asleep, please don't do that in front of my bosses. But really, apply what you know from the demo we did the other day, the lab we did on Monday, or excuse me, yesterday, and as well as the simulation that you did today on the computer. Hopefully you still have the computers, and if you need the computer to go back to the FET, the demo, the virtual lab, and see, I'm sure that the person who's in charge of you, I do believe it'll be Mike, will let you go back on it. So please write down any questions you have. Once you have finished your gas law problems, you should put them in the basket, and that should be your ticket to go. So if you do not finish them, they become homework, and I'll look at them on Wednesday. So everyone have a nice day. Please remember to go vote if you're registered. It's very important. And have a great day. Squirrel! Talk to you later. Bye. Except I don't know how to stop. Oh, here we go. Bye.